we're calculating the total surface area of a cylinder. So if we have a look at a cylinder here, I've got my tin of baked beans and I have rolled the label off to show you just how much surface area we have. So if we had to draw a 2D net of this cylinder, it would look like the two circles of the top and the bottom, right? Top of the tin, bottom of the tin. But then we also have this label that runs all the way through. So we have that label actually is a nice clear rectangle all the way through, okay? The rectangle is made of two dimensions. This one is the height of the tin, right? How high it stands goes from circle end to circle end. This bit here though, the length of the label is actually wrapping around this whole circle. So the length of this label is the same as the circumference of this circle. And we know that this circle's circumference, it equals pi d or 2 pi r. Now I'm just going to write that here. Circumference is equal to 2 pi r, or it's equal to, pi d. I'm going to use pi d in this lesson. If you need to use the other one, please do, but I just find it keeps it a little bit neater when we're starting to talk about some of these rules today. So we also know that the area of the circle is pi r squared, and then we know we have two of them. So if we looked at our total surface area, we have two of the circles, so 2 times pi r squared, plus this rectangle here. Now this rectangle in any other circumstance would be length times width, right? But in this case our length is the circumference. So instead of writing length times width, we're going to write circumference, pi d, times by the width. In this case it is our height. So even though that looks quite confusing, what this is doing is saying I've got two of these circles and I am adding in that rectangle label that goes all the way around the circle, pi d, and multiplied by height. Pi d here and height here. If I only had a half a cylinder though, and having a look at its 2D net, it would look quite different. It would have the half circle, but it would have this flat rectangle that it is laying on in this picture. Okay, that's going to give us this side, the flat bottom, and the other side. We still need the part that arcs over the top. So this, when flattened out, would still be a rectangle. It would just arch all the way over the top of these part circles here. So if we look at each of these, we can go, all right, we've got total surface area, it's going to equal a half circle plus a half circle plus our skinny rectangle plus our larger rectangle. So 2 half circles will equal 2 times pi r squared divided by 2. That's our 2 half circles. We are adding in, let's do this rectangle. Remember, this is our diameter from edge of the circle to edge of the circle, and this we're going to call our height. In this case, if we stood this up, that's how high it would be. So we're going to have a length times width, but instead we're going to say height times diameter. And then we are adding in this rounded section over the top. And we know that this one is height, so we're going to have height times, and this half circle is like a half circumference, and it's going to wrap around here. So remember, our circumference is pi d, but we only want a half of it. Okay, so that's quite a complex set of formulas there. I want you to picture, every time you're doing a cylinder, I want you to picture the unfolding of the baked bean label so that you can remember this section here is that circumference multiplied by the height. And when you are doing this, remember to draw that net first. We've got this base shape on the bottom, our 2 half circles, and the label or whatever it is that would fold rounded across the top.